Today's lesson is over regressions and curve fitting. And today we're going to be focusing on linear and quadratic regressions. And I'm going to show you how to perform these regressions on your TI 83 or 84 calculator. So let's review a little bit. Recall that a scatter plot is a special type of graph that has points plotted to show the relationship between two sets of data. So you recall you were used to a scatter plot with no correlation, a positive correlation, or a negative correlation. And previously, you've used a line of best fit to model the data. But what do you do when the data isn't trending on a line? Like a line of best fit, we can use a curve of best fit to model a data set. And then we'll make predictions using the equation for the curve of best fit. So this is what I'm moving into. We've got two scatter plots below, and you're going to choose between a linear or a quadratic model that would best fit the data graphed, and then we're going to write our responses down. So in this graph on the left, you can see that obviously it's trending in a line, right? So this might be, we might use a linear model to model this data set. That would be, we would use a line of best fit. But as you can see in the scatter plot on the right, this isn't trending toward in a line. It's more curved. So rather than a line of best fit, we might use a curve of best fit. And in this case, we're going to be focusing on quadratic models. Linear and quadratic today. There are obviously many others that you can use. Today we're using linear and quadratic regressions. So down here, here's some notes for how you can use your TI 83 or 84 calculator to perform your linear or quadratic regressions. And I'm going to show you how to do this on your calculator. Okay, we're going to be entering in the data right here. Then we're going to calculate the regression. And here's our linear regression. Here's our quadratic regression. And then I'll also show you how to turn on your diagnostics. You also might have something that looks like this. If you're using Desmos, this right here will show you how to enter in your data into your list and then how to perform your linear or your quadratic regression. And the key is making sure that you enter in your equations correctly. So let's move on. Practice finding regression equations. The directions say perform a regression for each set of data below, round all decimals to the nearest hundredth, then use the regression equation to predict the value of y given the value of x. So I want you to get your calculator and follow along as I walk through the steps for how to find a linear regression and a quadratic regression for these two sets of data.
When I'm using my TI 83 or 84 calculator to perform a regression, I need to enter the data into my list. So when I'm using my TI 83 or 84 calculator to perform a regression, I need to enter my data into the calculator. To do that, I'm going to click on this button right here, Stat, and then I'm going to click Edit. That's number one. I'm going to enter all my X values into L1, list 1, and all of my Y values into L2, which stands for list 2. So let's just go through the X values. 4, 4, 2.5, 3, 8, 8.5, and 9. And then I'm going to scroll over to the Y values, 9.5, 10, 9, 9.2, 11.5, 12, and 12.5. One of the things that you need to make sure of whenever you do your regression and you get your equation, if you come up with an error, a lot of times the problem is you've entered in one too many X values or one too many Y values. So you want to make sure that when you enter in your data, you have just as many X values as you do Y values. So now we have our data entered into our calculator, and now we're going to perform our linear regression. So I'm going to go back into stat, and I am going to show you, if you want to get out of this screen and go back to the home screen second mode, that'll take you there. I'm going to go back into stat. I'm going to scroll over to calc, and we're going to go down to linreg, linear regression, ax plus b. It's number 4. I'm going to press enter. It shows that I've got my L1 values, or my X values. List 2 are my Y values. I can store the regression equation, and I'll show you how to do that later. And now I'm going to calculate it. When I do this, it gives me the value of A and B. And you're probably used to seeing Y equals MX plus B, but your calculator says Y equals AX plus B, which means A is your slope. I'm going to round it 2 decimals out. So that's 0.51. B is your y-intercept, 7.69. If I round that 2 decimals out, I'm going to get to 7.7. So my regression equation is y is approximately 0.51x plus 7.7. The next thing on your notes says to predict the value of y when x is 14. So we're going to use that regression equation, second quit, and I'm going to predict the value of y when x is 14. So I'm going to take that equation, 0.51, and instead of writing x, I'm going to plug in 14 for x. So 0.51 times x, which x is 14, plus 7.7 is 14.84. So we've taken our data, we've plugged it into our calculator, we've performed a linear regression, and then we use that equation to make a prediction. I'm going to go back into my table so you can see our data set right here. Look at all these x values. They range from 2.5 is our lowest value, 9 is our highest value. We made a prediction when the value of x is 14. That's not within that range from 2.5 to 9. It's outside of our data set. When we make predictions based on data that's outside of our data set that we're given, we are extrapolating. So that's when you extrapolate data, right? You are making predictions based on data outside of your data set, outside of the data that you're given. So now I'm going to perform the quadratic regression for the table that's on the right. I'm going to clear my calculator here, second plus 712. You don't have to do that. That just clears everything out of your list. So now if I go to stat and enter, right, I'm going to edit, those lists are cleared. Another thing you can do is if you scroll up, you highlight that L1 and then you press clear, enter, it'll clear everything in the list. And I'll show you that again. So now let's enter in all the data from this table. So I've got 3, 2.5, 2.5, 1, 3, 3. Now I'm going to scroll over to the y values, 9, 7, 15, 24, 21.5, 3, and 4. And so again, we're making sure we have just as many x values as we do y values, and we do. Now I want to perform a quadratic regression. So I'm going to go back into stat. And again, if you want to go to your home screen, second mode, I'm going to go back into stat. I'm going to scroll over to calc. And now we're not performing a linear regression, we're performing a quadratic regression. That's number 5. So I'm going to click that. I've got my list 1 values, and those are my x values. List 2, those are my y values. I'm going to show you how to store the regression equation in a second. And now let's calculate it. And because we're dealing with a quadratic equation, we have values for A, B, and C. And I'm going to round it 2 decimals out. So my regression equation would look like this. Y is approximately negative 6x squared, right? I rounded that a value, minus 5.67x plus 27.37. That's my equation. That's my regression equation. So now I want to show you something. Let's see, we've got data in stat, right? We've got data in our lists. If I go to graph, I can't see this data. But let's say I want to see what it looks like when plotted on my graph. We're going to turn our stat plots on. So I'm going to click on second y equals, that's stat plot, it's a second function. And we want to make sure that this plot 1 is turned on. So I'm going to click enter. And I'm going to make sure on is highlighted. I'm going to press enter again. And this just tells me what it all is, right? I've got the on type. It's going to plot a bunch of dots. Everything in list 1 are x values. Everything in list 2 are y values. It's going to plot little squares and they're going to be plotted in blue. So now if I graph it, it kind of looks like this. But if you look at your table of values, which I know I don't have on the screen, but if you look at your table of values, which is right here, our x values range from 0.5 to 3, right? That's not a whole lot, but our y values range from 3 all the way up to 24. So if I go to my window right here, I'm going to change my y maximum. My y maximum is at 10. I'm going to make it 26. Now, when you graph it, you can see what it looks like. And we could change our window differently so that, you know, we kind of get rid of all that extra space. But what we did there is we changed our window so that we could see higher up on our graph. Okay. So now what I'm going to do is I'm going to do this quadratic regression again. Stat, I'm going to scroll over to calc. I'm going to go down to quad reg, that's number 5. And I could calculate it. In this case, I'm going to go ahead and store this equation into y1. So I'm going to store it. I'm going to go vars. That's this button right here. It's now highlighted in red. I'm going to click that. Scroll over to y vars. You don't have to do this at all. I just have students every year that think this is kind of cool. So then I'm going to click on function number 1. I'm going to store the function into y1. So now I've told my calculator to store it in y1, and now I'm going to calculate it. And boom, there's no rounding that needs to take place. If you go into y equals, there's your equation exactly as it is. And now, because I've stored it in there, I don't have to type anything in there. And if I graph it, I can see there is my regression equation graphed. There's my curve of best fit for this data set. I would say that's pretty good. So now we're going to use this equation to predict the value of y when x is 2. Now, because I stored that equation into y1, I don't have my rounded equation, and I'm going to use the rounded equation for this problem. So I'm going to go out, and we're just going to plug in our equation, which is negative 0.6, and we want to make sure we put negative down here, not minus, negative 0.6, and then we're plugging in 2 for x. So I'm going to plug in 2 for x, and then I'm going to square it. So negative 0.6 x squared, right, minus 5.67 times 2. Let's plug in that. I'm not plugging it in very fast on here. Plus 27.37, plus 27.37. And then we'll press enter, and I get 13.63. If I had plugged in, you know, and I rounded this equation right here, and that's why I wanted to show you this on this home screen. I rounded my decimals in this equation, but if I go into y equals, I didn't round it. If I look at that table of values, so second graph, When x is 2, y is 13.6. Oh, it's 13.63 as well. So that was fine that we rounded. Sometimes it gets a little off, right? So it might be like 13.65 or something. It might just be a little bit off because we rounded our decimals, and the answer that we wrote down, or the answer that's on our home screen, which is right here, we rounded those decimals, but we didn't in y equals. Now, the other thing I want to show you is we were making a prediction. What is y when x is 2? If I go look in my data in my table, when x is 2, well, I have a y value when x is 2. Well, this is just a random sample of data, right? We performed our regression so that we are able to make better predictions from data. And I'm asking you to find the value of y when x is 2. Well, when x is 2, is that within our data set? Our data set ranges from 0.5 to 3, or is it outside of our data set? It's inside of our data set. So when we're making predictions based on data inside the data set that we have, we are interpolating. Okay, that's interpolate, to make predictions based on data inside of your data set. So that's how you would do that, your linear regression and your quadratic regression on your TI 83 or 84 calculator.
What I'm going to do now is write down what we just found on our calculator. So our regression equation for this first one, I just want to make sure that you wrote it down correctly, is 0.51x plus 7.7. And then we found that when we plugged in 14 for x, we got 14.84 for y. In this second equation, our regression equation, is y is approximately negative 0.6x squared minus 5.67x plus 27.37. And when we plugged in 2 for x, we got 13.63 for y. So I just want to make sure that you have this correct in your notes. Let's move on to the next section. How well does the model fit the data? So in this section right here, we're going to be talking about something called the coefficient of determination. This is the value of r squared. It measures how well the regression model fits the data. So now when we're plugging in our data into our calculator, we are going to have our calculator calculate this value right here, the coefficient of determination. That number is going to be a decimal from 0 to 1. The closer the value is to 1, the better fit the model as the data. So the higher that decimal, the closer it is to 1, the better fit the equation is for the data. And obviously, if you have an r squared value of 1, what would that mean? It would mean it's a perfect fit. So let's move on. Grab your calculator, and we're going to plug in this data into our calculator, and then we're going to perform both a linear and quadratic regression. We're going to make sure our diagnostics are on, and we're going to record the regression equation and the value of r squared in the spaces below.
Calculator, second plus 712, and now I am going to, given this data set, find the linear regression equation and the quadratic regression equation. But the first thing I want to do is turn on my diagnostics. How do I do that? One way that you can do this, you can always go to catalog down here, which is in blue. It's a second function, so second 0, and find diagnostics. Or you can go to mode, click on mode, and then we are going to scroll down all the way until you see diagnostics, stat diagnostics right here. Stat diagnostics are off. I want to highlight on and press enter, right? So right there, stat diagnostics, I want to turn them on. So now second quit. So that is going to give me my coefficient of determination. Now when I do my linear regression and my quadratic regression, it's going to show me how well that equation fits the data set. So now let's plug in this data into our L1 and L2. So go to stat, and then edit. And now let's plug in this data set. So 2.8 for X, 2.9, 3, 3.1, 1.8, 1.25, 0.5. And now let's go over to the Y values. We've got 15, and then 11, 6, 0, 50, 55, and 46. And again, we're always making sure we have just as many Y values as we do X values. Otherwise, it will give you an error. And now we're going to perform a linear regression using our calculators. So we're going to go to Stat, then where do I go? Calc, scroll down to linreg, that's number 4. I can just press 4. We've got L1 and X values, L2 and Y values. I'm not going to store an equation, I'm just going to calculate it. And now, as you can see, we're given our equation, our slope, which is negative 20.42, and our y-intercept, 70.91. If I were to write that as an equation, it's y is approximately negative 20.42x plus 70.91. What you also need to write down is your r squared value, 0.80. You can write 0.80458, 6, whatever, however many decimal places you want to take it out, that's fine, okay? But your r squared value, that's your coefficient of determination. This tells you how well this equation fits your data set. So we did a linear regression, we've got an r squared value of 0.8. Let's remember that. Now what I want to do is go into Stat, go to Calc. I'm using the same data set, and let's do a quadratic regression. That's number 5. So I'm going to click on 5. I've got everything as it should be. I'm not storing any equation right now unless you want to, and now we're going to calculate it. So now in our quadratic equation, we've got an A value of negative 15.9. We've got a B value of 39.4, or 39.41, and a C value of 30.4. And our r squared value is much higher than that 0.8, it's 0.99. The higher the r squared value, the closer it is to 1, the better fit your equation is to your data. So now we've done these 2 regression equations. Which one best fits this data set? The quadratic regression, it best fits the data set because the value for r squared right here is higher. It's closer to 1. It's a better fit.
Linear regression equation we got was y is approximately negative 20.42x plus 70.91, and our r squared value was 0.8. Our quadratic regression, the equation was y is approximately negative 15.9 times x squared plus 39.4 x plus 30.4, and I'm just writing this down because I want to make sure that you wrote it in your notes correctly, and the r value was 0.999. So which model best fits the data in the table and why? And you might notice that I say data and data, I just interchange those, and whatever comes out, comes out. So as you can see, the r squared value for our quadratic regression is higher, which means the quadratic model, let's write this down. The quadratic model best fits the data, and why best fits the data because whenever you see y, use the word because is your friend, use it, because the value for r squared is higher, or the value for r squared is closer to 1, whatever you want to say. That is why we would use our quadratic regression that's the curve. We would have a curve of best fit, not a line of best fit, right? That would be the equation that best models this set of data, and that would be the equation we would use to make predictions. Let's move on to our next section, which is quadratic regressions and making predictions. In this example, it says, according to the CDC, the number of measles cases in the United States reported by year for several years are recorded in the table below. We're going to enter in this data into our calculator, and we're going to perform a quadratic regression. We're going to find the value of R squared, and then we're going to use the regression equation to predict the number of measles cases in the U.S. in the year 2025. Now, we don't put in years into our calculator, but the very first year, 2014, would be year 0. Every year after that is how many years it's been since 2014. So that would be year 1, year 2, 3, 4, 5, and then the year 2025. How many years after 2025, after 2014 is 2025? Well, you can always do 2025 minus 2014, and you would get 11. So we would be looking at what is y when x is 11. So grab your calculator and let's do some statistics here.
What we're going to do is enter this data into our calculators. So I'm going to go to Stat, Edit, and I'm going to enter this data into my list. And remember, I'm not putting years in. I'm going to start with 2014 is year 0. And then we're going to go from there. 1, 2, 3, 4, and 5. And then I'm going to scroll over. My Y values are 667, 188, 86, 120, 375, 1282. So I've got my data entered into my list. I can turn on my stat plots if I want to graph it. So second y equals, and I want to turn those plots on. So enter, I'm going to make sure on is highlighted, enter again. And now I can exit that, second quit. If I graph it, I can't see anything because if I look at my table of values, I've got some really high Y values there. My highest Y value is 1,282. So I can go into Window, and let's change that Y maximum because my highest Y value is 1282. So I'm going to plug in 1,300. That's my highest. Oh, that's not what I want. My highest Y value is 1,300. And because I don't want it to count by ones, I'm going to have it count by hundreds here. So my scale right there is by 100s. And now if we graph it, now we can see those points plotted. And you can see that, hey, this is kind of taking the shape of a quadratic. I can visually see that my points do not fall in a line. So if I were to guess the regression equation first, I would guess a quadratic. But this actually tells you to find the quadratic equation that best models the data. So now we're going to perform the quadratic regression. So I'm going to go back into Stat, scroll over to Calc, and I'm going to go down to Quadreg, quadratic regression. That's number 5. I'm not going to store any equations in, but I could go to Calculate. And there are my values for A, B, and C, but I need the value for R squared. What did I forget to do? I forgot to turn on my diagnostics. So we want to make sure we go to Mode, and I'm going to go all the way down to Stat Diagnostics, and I'm going to make sure On is highlighted. We want our calculator, scroll over to On, to tell us how well our equation fits our data. So second mode. Now I'm going to perform the quadratic regression again. So Stat, scroll over to Calc, Quadreg, that's number 5. Enter, calculate, and now we have our value for r squared. That's 0.97. That's really close to 1. That tells me that this equation fits our data set really well. So I'm actually going to round all of these, okay? I'm not going to plug it into, or I'm not going to store this equation into y equals. I'm going to round all of these values for a, b, and c. A, I'm going to round to 149.25. It's there. B, I'm going to round to negative 641.39. C, I'm going to round to 688.36. Then I'm going to plug in this equation into y equals. So 149.25 x squared. Oh, that doesn't do that. I use my keyboard. Delete. X squared minus 641.39 x plus 688.36 plus 688.36. I've got that equation in y equals. Now that it's there, I'm going to graph it. And it should graph my quadratic regression. And there's the equation, or there's the curve that best fits this data set. Part C says, use this regression equation to predict the number of measles cases in the US in the year 2025 if the trend continues. If the trend continues, right? If nothing is done about it. So what I can do is what I did on the previous problems, go back to the home screen and plug in 11 for X. Now, why would I plug in 11 for X? If I'm looking for the year 2025, that's 11 years after my starting year, which is 2014. So we're looking for what is Y when X is 11. One of the things I can do is second table. I can go to my table and I can look at what is Y when X is 11 in this equation. 11,692. 11,692 cases. That's what we would predict.
Here's what we just went through written down. I want to make sure that you have this in your notes correctly. We've got our quadratic equation up here, our regression right here. Our value of r squared is 0.97, and we use that equation to make a prediction. If the trend continues, there will be 11,692 cases of measles in the year 2025. Let's move on to the last section in today's notes, linear or quadratic. This says the average maximum temperature in Austin, Texas over a 6-month period is shown in the table below. The problem says to find the linear equation that models the data, then find the value of r squared. Then we're going to find the quadratic equation that models the data and find the value of r squared. Then based on that information, we'll determine which equation best models our data, and then we'll use that equation to predict the maximum temperature in Austin in December. Now, I do want to point out, we're obviously not going to put in May, June, July into our calculator, but that first month will be month 0. Every month after that will be how many months it's been since that first month. And then when we're making a prediction for December, how many months after May is December? 7 months. So we're going to be looking for Y when X equals 7. So get your graphing calculator and let's plug this in.
In this last example, I'm going to be performing a linear and a quadratic regression, and I'm going to determine the equation that best fits this data set. So first, let's plug in this data into our calculator. So I'm going to go to Stat. This is not letting me. My mouse isn't moving. So I'm going to go to Stat and Edit, and I'm going to enter in this data into L1 and L2. And instead of my months, my first month is going to be month 0, and then from there we'll go 1, 2, 3, 4, 5. So we've given these months numeric values. And now L2, those are my temperatures. Let's see, which is 88, and then 92, 97, 98, 91, and 82. So again, we're making sure that we have just as many X values as we do Y values in our table. And now I want to turn on my diagnostics because I'm performing a linear and a quadratic regression. I need to use that coefficient of determination, that R squared value, to tell me which model best fits my data. So I'm going to go to mode. I'm going to make sure that stat diagnostics are highlighted on. So we're going to go all the way down and I'm going to scroll over to on and I'm going to make sure that it's highlighted. And let's get out of this screen. So second mode or quit. Now we're going to go to stat and let's perform our linear regression. Where do I go? Calc. LinReg is number 4. I'm going to click on 4. I'm not going to store this equation anywhere. I'm just going to calculate it. And then let's make sure that we write this down. So when I write down this linear equation, its y is approximately negative 0.91x plus 93.62. So I've rounded to that 2 decimal places out, right, to the nearest hundredths place. And I'm making sure that my a value, that's my slope, that goes in front of the x value. B value is my y-intercept. And then my value of r squared is 0.08. I don't have a lot of faith in this equation. 0.08. That is how well this equation fits this data. Now let's perform our quadratic regression. So stat, scroll over to calc. Where do I go? Number 5. And I'm going to go all the way down to calculate. I can just press enter or the down arrow. And it will calculate my quadratic regression. If I were to write this down as an equation, because I'm rounding all of my decimals, y is approximately, that's not an equal sign, it's like a squiggly equal sign. Y is approximately negative 2.02 x squared plus 9.18 x plus 86.89. Value of r squared is 0.95, which is clearly closer to 1 than the r squared for the linear regression, which means the quadratic equation best models the data because the value for r squared is higher. So we're going to use that quadratic regression to make some predictions. F says to use the equation that best models your data, which is this quadratic equation right here, to predict the maximum temperature in Austin in December. Recall that in our table, we have, let me pull this up, month 0 was represented May. It's asking us to find the maximum temperature in Austin in December. How many months after May is December? June, July, August, September, October, November. That's 7 months. So we're looking for the value of y when x is 7. What I'm going to do, I'm going to plug in this equation into y equals. And now my calculator is going to not do anything.
Everything that we just found on our calculator, and I've written that down in your notes. You can pause the video and make sure that you have everything written down correctly. We did our linear regression, and let me write this down. We did our linear regression, we found the value of r squared. We did our quadratic regression, we found the value of r squared. And then the equation that best models our data, we said was the quadratic equation. Why? Because the value of r squared is higher. It's closer to 1. It's a better fit for our data. And then when we used this equation right here to figure out, or to predict, right, that's what we do, to predict the maximum temperature in Austin in December, we plugged in 7 for x and we got 52.17 for y. Oh, actually, we didn't do that. Let's do that now. I'm going to plug that in. So I've got my equation, y equals negative 2.02. So negative 2.02 times 7 squared plus 9.18 times 7 plus 86.89. And you can plug that into your y equals and look at your table of values when x is 7, or you can just plug this into your home screen to find the value of y when x is 7. And what do you get? 52.17 degrees. That's our units, 52.17 degrees. And that concludes your day 1 notes over regressions and curve fitting, focusing on linear and quadratic regressions. I hope it was helpful.